Switzerland. Yoko, the head of the Science and Technology Office, Tokyo, the Embassy. I'm very pleased to be your moderator for the EPFL Virtual Space Tour. The day 4 EPFL Virtual Space Tour brought to you by EPFL Space Center Space at at EPFL, excuse me, EPFL, Swiss Federal Institute of Technology in collaboration with the Science and Technology Office Tokyo, Embassy of Switzerland in Japan. The EPFL Virtual Space Tour is a science communication project or is centered around two very new science communication projects. One is the Virtual Reality Universe Project, VIRUP, which was developed at the Laboratory of Astrophysics, LASTRO, at EPFL. This VIRUP project takes you to the most detailed map of the universe in a very immersive style using virtual reality technologies. In our venue at Tokyo Midtown Hibiya Base Q, we have some demo experiences where you can try out the VIRUP contents with VR goggles. The second one, the second science communication project that we bring to you as an experience in Tokyo, only unfortunately this time, is the Tranquility Base. The Tranquility Base is a virtual escape game. It is based on a physical escape game that used tents and had people in teams join the tent and collaborate with each other to save this, the lunar mission. However, under circumstances where we are all required to keep social distancing, the developer of this escape game, the EPFL Student Association Space Satire Service, evolved the game into a virtual version and gave it a whole new scenario, but still with very scientific background. And now the Tranquility Base virtual escape game is brought to you through your app stores and Google Play. So please also check this out. You can find the download links from our EPFLvirtualspacetour.com website. These two science communication projects are at the core of our EPFL Virtual Space Tour. But on day 4, we have a very, very interesting talk event that we are bringing to you right now. And I would like to jump right into it. However, I have some small notes for you, especially for our online viewers. So we will go through all the presentations before we can come to the Q&A session. However, you are very welcome to our online viewers. You are very welcome to already put in your questions in the chat boxes of the streams that you are looking at. If you are looking at our Japanese channel, please feel free to put in your questions in Japanese. This is not a problem. Furthermore, for the people at the Tokyo venue, at our physical site, please make sure to mark your questions so that you do not forget. So without further ado, I am very pleased to bring to you Careers in Space, Focus in Astrophysics and Space Exploration, with our first speaker being Professor John Paul Knipe, Director of EPFL Space Center, eSpace. John Paul?
Hello, all. Nice to be with you from back in Switzerland. And so to start with my my point, I will share my screen and show a few slides about the work we're doing at EPFL. So Can you share? Can you see the screen correctly?
Yes, now it's perfect.
Okay. So I'm gonna bring you through the EPFL Space Center, in short eSpace, that I'm a director of. I'm also professor in astrophysics, and it's in some sort of way also to go and be launched in space. What I'm gonna show and explain in the next few slides is how important is the interdisciplinarity aspect of space. And in fact, the way EPFL Space Center is designed, it's what we call the center on the campus. And it's not linked to a special laboratory, which are very specialized. It's a structure that is trying to gather projects from various disciplines across campus. So we have about 20 employees. We're working with 35 different laboratories that have activities in space. We also train many students. About 82 minor space technology students are working with us. And we support 6 interdisciplinary student projects that I will explain a little bit. And in particular, Chloé Carrière later on will explain her particular project, a team project. So what's our mission at EPFL Space Center? We aim to educate, we aim to do research with professors and industries, and we want to innovate so that we create new work related to space. So we focus on space science, which is including astrophysics and technology. But we also care for the future, and we look at this mission considering sustainability. So all the projects we are developing these days are trying to address this sustainability issue. And why so? Well, we live on a tiny planet in the universe, and there's no planet B. And that's all we learn by looking at the universe. And I like to make this link of being a small thing in a big thing as a way to think better on our world. So what are our activities? We have 3 pillars: education, research, innovation. For the education, we're really trying to educate EPFL minor students about space, what it is, how it works. And we also accompany them in interdisciplinary projects through what is called at EPFL the MEC Fund. These projects are aiming to develop capacity outside the school hours of projects related to space. And I'll describe a bit later others, the details. In terms of research, we're trying to bring research and innovation, because it's through research that you lead to innovating products or missions or projects. And we have one particular dedicated mission, research project on sustainable logistics and cleaning the space. Other projects are very different, and they're really connecting various labs together and trying to promote new ideas on how to work, for example, in Earth observation using machine learning. So we really try to have different connection from different type of science in the context of the space science and technology. But we also, what's for us also, it's very important, and it's across these 3 pillars, is the communication and outreach. And the example of this event is one of the ideas we have is that not only we have to educate, research, and innovate, we also have to communicate to the world, to the people, what's important. So just a quick view on the different student education and team project. So we have a minor in space technology. It means our students at EPFL who are doing robotics or I don't know, astrophysics or life science, they want to know a bit more space, well, they take our minor in space technology. And here they would have some dedicated course related to space and how it works there. So we're bringing those students, and some of those students are leading, very interdisciplinary project and very innovative projects sometimes. So we have, for example, the rocket team who's building rockets. They launched that at 3-kilometer altitude in a competition in the US. We have the Explore project who develop a rover to go on Mars or maybe on the moon. We have the Callista, which is an astronomy group of EPFL who want to build a radio telescope, or they want to follow satellites using small telescope. Or we have the Grobot Hub who wants to grow plants in space. And so they have to do that in a robotic way. So that could also have some interest in the future for society on Earth. And we have a small spacecraft team who wants to launch some CubeSat. And finally, we have Space Task of Service, and Chloe will mention that in details a bit later. We participate in big projects like the SK Observatory, who's trying to observe the sky in radio domain. This project is really just starting construction, and eventually it will flow a lot of data, 700 petabytes a year in a couple of years. So this is a really big data project. So here we have a good connections with computer science, with machine learning, with HPC experts to develop this project. Also in astrophysics, we have another project, and the VREP presentation is basically directly linked to this project. We are developing instrumentation, robots to observe galaxies and to observe many galaxies. And that allows us to draw the 3D position of galaxy in the universe. And by looking at the position of those galaxies in the universe, we can analyze the data, derive properties of the universe, in particular dark matter and dark energy. And then we can visualize this data in 3D using advanced computing visualization tools. We also very careful, as I say, of sustainability in space. And today we can be sure that space debris cannot be denied anymore. And we need to do clean space. And it's only by cleaning the space we can make it sustainable. So we had a crazy idea a couple of years ago, but 10 years ago, is to go and fetch the Swiss Cube, the first Swiss CubeSat that was made by EPFL students. And well, this crazy idea grew, and now it's a startup with a mission by ESA to go and collect debris from the ESA, the European Space Agency. So to conclude, I want to say that space is extremely interdisciplinary. If you are interested in space, there's a lot of room there. You can come with, robotics view, with law view, or I don't know, life science, any discipline basically. And all these discipline can launch you in space. Thank you.
Thank you very much, Professor Kneip. This was for the comprehensive overview. It was very fascinating to see that you also support the student projects in this sense, as is the case with Space at Your Service. So now I would like to move on from the introduction of the academic supports that were given to the apparently we are. So to people online and also to the venue, excuse me, apparently the mission experienced a little bit of hiccup. But it seems to be under control. And I will talk a little bit longer for about the background then, perhaps before we move on to our next speaker. Professor John-Paul Kneip, who just gave us the overview of the EPFL Space Center, introduced to us the academic start, what our students or what people can study for a career in space. And this was mainly at EPFL, at the Swiss Federal Institute of Technology in Lausanne. We are also here to support people from Japan on their interest to study in Switzerland. So if anyone who has seen today's program or any of our other programs or have experienced these very exciting demos that we offer with the Virtual Reality Universe project, and also the Tranquility based virtual escape game, and are interested in learning more about the science behind these, or just of these activities that you could experience if you were a student at EPFL, and these sound really exciting opportunities, please look up the EPFL website. It's very simple URL. It is epfl.ch. Or please contact us at the Science and Technology Office at the Embassy of Switzerland in Japan. Okay, so I have the green light to move the mission forward. So now I would like to introduce to you Professor Genya Ishigami, Department of Mechanical Engineering, Faculty of Science and Technology at Keio University, who will introduce us the different opportunities of working in space based on his own experience. Professor Ishigami, please.
Yep. Thank you so much for kind introduction. I'm Genya from Keio University. Could you please start the slide? All right. Today, I'm gonna share with my experience in past 10 years in order to, talk about the career in space. Actually, the career in space, as Professor Jean-Paul said, we need to have interdisciplinary or multidisciplinary aspects. So let me quickly introduce myself. I got my PhD at Tohoku University in Japan, 2008. And after that, yeah, please start my slides. Or do I have to press the forward button? Anyway, and after I got my PhD, I worked at MIT as a postdoc for 2 years and worked at JAXA for 3 years. And it's been 8 years after I got my faculty position at Keio University. And during these 10 years, wow, I have been devoting myself to several space missions as well as robotics projects. Yeah, perfect. Thanks. So I will share those topics very, very quickly and share my experiences. My research interest includes space exploration, as I said, and I am very much interested in deploying my robots in field. So my main application will be related to planetary exploration as well as volcanic exploration or even in unmanned construction. Yeah, here's some movies that should have been played, but not here. I have developed several robots at MIT and JAXA, and please see the bottom left figure, which indicates the Spirit. Spirit is a Mars exploration robot developed by NASA. In 2009, this Spirit was trapped by fine-grained soil on Mars. And it is very, very unlucky situation, but for me, I could participate this project for analyzing the mobility performance in order to take it off from the sand trap. And I will quickly share my memory about the turning point from space agency to academia. As you may know, the Hayabusa, the small space probe, and fortunately, I could join the capsule retrieval campaign. I will quickly introduce the Hayabusa, which is the world's first space probe to making a round-trip voyage between the Earth and an asteroid called Itokawa. And this space probe equips very small capsule in front of its probe and release it when this space probe returns to the Earth. And at some point, this capsule send a signal to the direction finding system, which is basically the antennas. And I could join this campaign. The capsule was landed on the desert called Umera prohibited area in Australia, as you see in the map. This area is nothing other than desert and grasses or even kangaroos. And we deployed a lot of antennas over there, and you could see some photos in the left bottom, but I cannot identify where I am anyway. But I have a plenty of behind talk, but that time is limited, so I could join this project and share my experience with these guys. So why this is turning point for me? Because this Hayabusa mission started its conceptual study in 1985 and ended in 2010. So it took 25 years. And also I could join on, okay, could you forward the slides? Thanks. I could join the MIROS mission, which stands for the Mars Exploration for Life Organism Search. That should have been launched in 2020, but it was terminated. But anyway, I could join this mission as a system lead for robot designing. And I realized that the space mission often takes long time. And at this point, I realized myself that I would like to devote myself to space exploration, as well as to work with or run with next generation. So this opportunity will lead me to the academic position. So after I got my faculty position at Keio University, I worked with several students for developing some dynamic simulators for unmanned construction machine, as you see in the top right. And also we have developed small agricultural robot for farmers and established a company called Donkey Corporation. And in COVID-19 situation, I have worked with 3 faculties and 3 students to quickly develop a face shield, personal protection equipment for the Keio University Hospital, because those equipment was short in that situation. And also this is a good experience for me in 2020. We participated in the Cybertron and got 3rd place. And thank you so much for the great support from Science and Technology Office of the Embassy of Switzerland in Japan and this competition. And I've been devoting myself to several space projects, as you see in this slides. There's more to come, I guess. So this is the last topic of my talk, carrying space. As the Professor Jean-Paul said, the carrying space is basically related to the interdisciplinary aspects. If you are looking for a job in space, maybe you can devote yourself to scientists, engineers, or technicians. Yeah, astronauts is the hero in the space exploration, but medical doctor or psychologist will help their works. Architecture lawyer would be the next job in the future project or future space missions. And communicators is very, very important aspect to broaden the knowledge and experiences for the career in space. And most of people who are interested in space exploration or space things, most of them are focusing on space agency, JAXA or SSO, ESA, NASA. But in coming decades, I think, could you forward the slide? Thanks. The corporation, startups, or even university can set up their own missions and deploy their space probes or robots to the moon or to the Mars. Okay, could you go forward? Thank you so much. And next slide, please. This is the last slide, the take-home messages. I'm quoting from the famous words from, could you press the forward button? Yeah, great. That's one small step for man, one giant leap for mankind. This is quoting from the first man landed on the moon, Neil Armstrong. I think the small steps are very, very close to the classes in your university or researches, or even everyday work would be the small step. And there are a bunch of opportunities. And I think accumulating those small steps will lead you to the giant leap. So those giant leap will lead you to the future project at company, agency, or startups. So that's all of my talk. Thank you so much. And I'd like to have a lot of questions today. Yep.
Thank you very much, Professor Ishigami, for sharing your great tour through different agencies and different experiences. And today, to Professor Ishigami and to our audience, please excuse us for the glitch in the video. I thought that the thrill that I will have today was from the escape game, the Tranquility base, where there is a communication glitch. I thought that would be the thrill, but today I had a bigger thrill. So, but please excuse us. Now I would like to ask our two student speakers today from Japan, who will share with us the space education program called that is offered at the Tokyo University of Science. They will give you in more details what the program is, and we will learn how space education is broadened in Japan. Thank you. Excuse me, I have to introduce Mr. Naoyuki Ota will speak first. He is from the Department of Physics, Graduate School of Science at the Tokyo University of Science. And he shares his presentation with Mr. Taiki Kanda, Department of Electrical Engineering, Faculty of Engineering, Tokyo University of Science. Mr. Ota, please.
Thank you. I'm Naoyuki Ota, a student of Tokyo University of Science, and Mr. Kanda is also student of Tokyo University of Science. So we are going to talk about space educational program at Tokyo University of Science. And first of all, I explain overview of space educational program. The purpose of it is to build and expand human resources based for space science and technologies. And the program consists of 3 major contents: lectures, hand-on learning, and group experiments. These curriculums are held through 6 to 9 months, and students of university or college and high school students can attend the program. And in each time, to 20 to 30 participants attended, and external collaborators cooperate and evaluate the program. And one of the unique points of this program, graduates of the program is support as mentors. I will explain about its detail. And this program is commissioned by the Ministry of Education, Culture, Sports Science, and Technology in Japan since 2015. So 6 terms are offered since 2015, and I'm a student of 4th term, and Mr. Kanda, I'm a student of 5th term, and Mr. Kanda is a student of 4th term. So I explain lectures. Lectures are made by many experts on various fields related to space. In addition to professor of the US, many external experts, researchers, engineers, and so on, is support as speakers of lectures. And so students can acquire the cutting edge knowledge through these lectures. These photos are as example of speakers. Speakers for first and final lectures of each year. Left side photo is the Dr. Chiaki Mukai. She is both special vice president of the US and the first Japanese woman astronaut. And right side is Mr. Martin Gavetosh, agent representative of NASA. And these lectures are open to the public. So if you were not a student of the program, you could attend these lectures. The aim of it is to promote the fascination of space science and technologies. So everyone can acquire the cutting edge knowledge of the space related, some kind of space related engineering or science. And second content is hands-on learning. So this curriculum, program students can gain real experience. The major contents are the hands-on training and visitation to space-related facilities. As hands-on training, for example, rocket engine simulation, like light side photos, and simulation of air conditioning in space station modules. That is, students simulate convection of air, and also astronomical analysis. That is very interesting hands-on training. I enjoyed it. And student of program can visit many facilities, for example, JAXA, or that is Japanese Research Institute related to space, and or students can visit Access Space, that is space venture company, and so on. And third content is group experiments. This is most interesting and unique content of the program. The students set their own goals and decide the success criteria and manage their projects by themselves. Because of this, students problem-solving skills or teamwork skills are developed. Major contents of the group experiments are CanSat experiments and microgravity experiments. The CanSat is small size satellites, like left-side photos. CanSat requires many knowledge or skills. For example, electrics or some software development. And CanSat includes many aspects of spacecraft development. the most important point is that CANSAT needs auto sequence, the autonomous controlled device. So it is a very good opportunity for us. In microgravity experiments, we craft and make devices for science experiments under microgravity. The right side photo shows the public flights that airplane flight public projected publicly, and microgravity environments are made. Yes, this is very good opportunity too for us. And these experiments are done by 5 to 6 members. So students of the program divided to 5 or 6 teams and discuss each other. So these experiments are held through 3 to 6 months. And we have to do these project and the budget. So 50 to 80,000 yen. It is equivalent to 500 or also $800 US dollars. Through these experiments, we can many real experience too. And in 2020, as you know, during epidemic of COVID-19, we took advantage of online. It sounds like some negative change, but I think this is very positive things, because as Tranquility base made by EPFL students AR game, we have to contact each other by remote. So this is very similar situation to mission in space. In detail, instead of CANSAT development, we do remote survey of an unidentified object using rover, like left side photos. Cameras and many sensors are boarded on the machine, and we identify the objects. And our experiment in free-falling sensing, like right side photo, is alternative to microgravity experiments. We make devices for the science goal and experiment in like free-falling system. And in system, we use Cosmotore. This is produced by Weymouth Electric Corporation. Some professors or staffs of the US go on site, but students instruct them to prepare the experiment from their home by remote. So it is very similar to space mission. And in my case, fifth term, we have to change the public devices for public flight to these free-falling system experiments. So on the way, so this is very hard for us. So excuse me, please, next slide. Go. Thank you. So I have that with contents for students. So next, Mr. Kanda explain mentors.
Next, I introduce the mentor. Eventually, an effective system of this program is to allow the graduates to participate the program as mentors. Mentors mentors can experience both teaching and taught. This is very strong point of this program. We were also mentors in this last year's program. Mentors engage this program as instructors for lectures and hands-on training and to support for group work. The participants divide to 5 or 6 groups in CANSAT or microgravity experiments, and mentors take charge of each group. The mentor tell participants technical skill and team management skill. For example, how to advance these experiments preparations. And moreover, 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 mentors acquire the knowledge that participants discuss when we consider the experiment's contents with them. I introduced after space educational program. My case, I learned the management skill through the group experiments in this program. I apply it to organize an event in space-related circle activities.
Excuse me. In my case, I experienced the interest of creating a device with science goals. So therefore, I engaged in development of satellites, like small satellites for X-ray astronomical observation.
Yeah. Finally, I would like to introduce this presentation summary. The space educational program provides cutting-edge knowledge, real experiences, problem solving, and teamwork skills, and nurturing skills. Finally, I think this program built human resources base for space, science, and technologies. Thank you for our presentations.
Thank you very much, Mr. Ota and Mr. Kanda, for sharing the space education program at Tokyo University of Science and your activities after the program. It's very interesting to see for us. So I would also like to invite our audience to post your questions in English or Japanese on the chat boxes or to prepare them at the venue. Thank you. Now I would like to move on to our final speaker, who is the founder and previous president of Space at Your Service. And she will give us a great presentation on making student projects happen. Ms. Chloe Carrière. Chloe?
Thank you very much, Kyoko. So we'll go ahead and share my screen. Okay. Perfect. really an honor and a privilege to can you hear me? Kyoko?
We see your screen, yes?
And can you hear me correctly also?
It was a bit sounded like from the moon, but now it sounds fine.
Yeah, I had so as I was saying, it's a real privilege for me to be able to be there today and to witness the launch of the escape game by Space at Your Service, where Alexandre, that will be doing a presentation afterwards, has worked a lot with the STO office. So, but this is not the topic of my presentation. As you see, I've entitled it Taking the Road Less Traveled, and let me explain to you why. So as Professor Knaib and Professor Ishigami have explained to you, there's many different paths that you can take to work in the space field. We no longer only have scientists or engineers. And I like to say that to find your path, you need to go into different roads and sometimes less traveled. So this is why I've used this quote from Robert Frost: "Two roads diverge in the wood, and I took the one less traveled by, and that has made all the difference." And this is something that I did during my experience, and I'd like to share with you. Well, I don't have a resume as long as Professor Knapp. To work in a space field, I started with a bachelor in physics at EPFL. And at the end, I wanted to become an astrophysicist working for cosmology or discovering more about black holes or dark energy. And throughout my studies, I decided to create and found a nonprofit organization that is Space at Your Service. And this has made all the difference for me. Thanks to this experience and the side project that I launched, I realized that I wanted to do management of technology rather than doing actually physics. So this is why I decided to do a master in management of technology. On the side, I am also a science communicator, and I love communicating about space sciences in general, but also the different roles that made the space sector thriving today. So this presentation is about pushing the limits, pushing the boundaries. And this is how I think you can decide what you want to do afterwards. And this is a message for the young generations, but also maybe people who are a bit older and feel like they haven't found their way yet. And to do that, what we do at EPFL is that we get involved in side projects. At EPFL, we are very lucky because we have this set of interdisciplinary projects under the MAKE initiative, where we get to launch rockets, drive Martian rovers, simulate the moon, or for instance, promote space sciences. Jean-Paul has introduced many of them beforehand, and I want to introduce a bit more what we do at Space at Your Service. At Space at Your Service, we're known from your side for this virtual escape game that we've created. But we also organize many outreach events that we call Astronomy on Tap, where we bring scientists and engineers to the stage in bars to interact with the public. We also organize what we call analog space missions, which are a simulation of life on another planet or another celestial body to test technologies and educate the next generation. So here you can see a picture of the Vivalis mission. It's an educational program that we've launched with the Space Innovation to organize these types of mission for children. So we did one last year with a class of 7 to 8 years old children, and they performed a 3-day analog mission on the analog Mars in Switzerland. That was, of course, a long preparation for them. They had 9 months to prepare and many knowledge to acquire to perform this endeavor. And the Asclepius mission is, of course, the big sister of the Vivalis mission. It's a large interdisciplinary project where more than 100 students were involved. And we aim at designing a mission for the moon. And I'm going to talk to you about it a bit afterwards. So I was mentioning this MAKE initiative, which is a set of projects that we have in universities where you get to do hands-on work. And we have many of them, and actually a lot of them are in the space sector. For instance, the EPFL rocket team who make rockets to take part in a competition. We also have the EPFL Explorer who builds Martian rovers and actually took part in their first competition this year and got 3 different awards. Or for instance, the Robot Hub, which is a robotic structure for agriculture on the moon, who took part in the Igluna campaign in Switzerland. Other projects are in process, such as the EPFL Situational Awareness Study, which aims at detecting space debris from ground using telescopes. And the EPFL spacecraft team, who wants to launch a constellation of satellites in orbit in the next years. Asclepios is part of those projects. It's a MAKE project recognized by EPFL as a project that contributes to the educational impact of the university. And our goal, as I've mentioned, was to simulate the moon. So here you can see a picture of our analog astronauts, the students that were isolated underground for 8 days, as if they were on the lunar, not surface, but actually the lava tubes, the tubes that are present on the moon. And they stayed underground at a temperature of 12 degrees for 8 full days, performing scientific experiments, either landed by a scientific laboratory or built by other students across the world. Next to them, a few kilometers away, was our Mission Control Center, where another set of students were simulating Earth. And their goal was to make sure that the mission went as good as possible and that we had the necessary scientific results to send to scientists. During this mission, we performed an educational study to see if there was a true educational impact thanks to this type of project. And here you can see a graph with the evolution of the space sector knowledge by the students according to the time they were in the project. And so you can see there's been an increase in, for instance, the knowledge on the space domain, on systems engineering, on Mission Control Center, and of course, in total. Why do I encourage you to join those projects? I encourage you to do that because it's a great opportunity to know if you were meant to do what you're supposed to do. At first, when I did my bachelor in physics, as I mentioned, I wanted to become a space engineer or astrophysicist. And I quickly realized that's not what I'm meant to do. I'm meant to do management of projects. And this is why I shifted and went maybe a bit to the dark side, as my fellow scientists would say, to do management. But apart from that, taking part in those projects, it fosters international collaboration. You get to meet international students with the same passion as you have. They get to learn soft skills and hard skills to develop your network, and as I mentioned, find your path. I did a quick look in Japan to see if you have similar initiatives, and I could see that, for instance, some of you took part in a YouTube Space Lab and actually won, and they also developed a satellite that is called Hoyu or Aoba in the Q-Tech University. So don't hesitate to take a look, and even if there's not what you want, you can always go ahead and found your own project, because that's exactly what we did with Space at Your Service. We had this idea of doing analog space missions, and there were none in Switzerland. So we started from scratch and we made it. And after 2 years of hard work, you could make it yourself too. What are the necessary ingredients to launch your projects or to take part in those projects? I tried to think about it and came up with these 5 key words. Well, first one is, of course, passion. You need to be passionate about what you do, and this is what will make you happy and make you do a good job. And this comes, of course, with motivation. If you're passionate, you are motivated. Resilience, because real life doesn't work as on paper, as you can see in your classes. And those projects are here for that as well, to test and to fail and to try again. So you need to be resilient. authenticity, and especially if you want to do science communication and finding your own path, you need to be authentic. Who are you and what do you want to do? And finally, inclusiveness. We live in a world where we hope that space will be more collaborative, and that next step when we step on the moon, it will be an international collaboration. And for that, will be to be more inclusive. So inclusiveness is also a keyword to start or take part in one of those projects. So then I want to show you a quick video that was very emotional for our team, because that was the moment where we realized that the Asclepios mission was finally launched after 2 years of hard work, and as I've mentioned, starting from scratch. So they were entering their underground airlock for the lunar base, and that's a video of the launch. Well, that's all that I wanted to mention to you, and I hope that you really keep this message for you. Don't forget to always shoot for the moon. Don't put yourself any barriers. You can make it. Thank you very much.
Thank you very much, Chloe, for sharing your interesting and successful projects with us. That was very inspiring. So now that we have received these presentations from all our speakers, I would like to invite the audience to ask questions, if you have any. I would like to maybe start with one that was already in the chat box. I believe this question goes to our student presenters about the space education program hosted at the Tokyo University of Science. The question is, are there specific goals that the space education program as a whole aims to realize? The goal of the space education program, is there something specific, or is it up to the students to decide what they want to achieve?
So the question is whether students can decide their goals. Yes, student of our program can please show slides. Could you show?
Can you share the slides for us again? Do you know which page? Do you know which page?
Yeah, page. I forgot last page or okay. Oh, excuse me. Yeah, student. In conclusion, students can decide their goals of their experiments. For example, this slide shows one of the theme of experiments. This team makes devices that measure dynamics of liquid. So as like left side photos, auto sequence make splash and move the device under microgravity and on Earth. So they compare the trajectory of the liquid. Like this, students can specific science goals. So is this?
So there is room for students to also set their own goals.
Yes, thank you.
If there is someone who would like to add about the program. Thank you. Okay. Then I would also like to invite the audience from Tokyo. We can also take questions in Japanese if you wish, you can ask the questions in Japanese and it can be translated to our speakers. So if you have a question, please raise your hand. Thank you. We have a question, and it can also be asked in English, of course.
Yes, it will be in English. Thank you very much. So maybe my question is for Chloe, if she's still here. I just would like to know, out of curiosity, what were the main scientific results out of these analog mission, besides the educational value of the whole program. Was there any key scientific advancement thanks to this?
Yes, thank you very much for your question. Unfortunately, I cannot see you, but of course, for the children mission, there were not scientific outputs, of course. But for the Asclepios mission, the student mission, we performed 10 different experiments during the mission. There was a software developed for flight plan purposes and optimization that was tested and was conclusive. We also had an experiment from the ETH University and the equivalent of EPFL in Zurich in geophysical exploration that meant at mapping the underground using seismometers. And we also had a psychological study on the impact of living underground. And actually, most of this research will be presented at the International Astronautical Congress. I don't know if you're aware of this conference that will be happening in Dubai. If you're interested, we will be publishing the results of those experiments by end of October.
Thank you very much, Chloe. We would also invite people to make to share their impressions from the presentations if you would like. Also in the chat box, if there is any feedback or impressions that you would like to share. Then I have also a question for the professors. Are you seeing an increase in students' interest in space studies and activities? Professor Ishigami, would you like to go first?
Yeah, I feel a lot of interest, increasing interest from the student, particularly younger generation. I think this is because there are several startups in the United States or in Japan has a lot of motivations or passions to explore the lunar or Martian things. So that's the main reason, I guess.
Thank you. Professor Kneip, do we also see rise in interest from the students?
Yes, in general, we have a growing interest. If we look at the people, wanting to register to the minor in space technology, I mean, there's always a larger number from each year. As Professor Ishigami said, I mean, there's new startup, but it's also, I think, the fact because it's becoming easier to go to space. A launch to send satellites is much cheaper than it was before, and it's much easier also to build, tiny electronics that doesn't weigh a lot. So with a very small budget today, you can be in space.
Thank you. Thank you very much. Would someone like to ask another question or share their impression? Please raise your hand if you have in the Tokyo venue. Thank you.
Thank you. I have a question for Professor Kneip. I think you were one talking about the space debris. In your opinion, how serious is is the situation about the space debris? And do you think that we will ever get rid of all the debris, or are there just too many of them floating around space? Thank you.
It's an interesting question, and I think it's a bit difficult to answer. To get a good answer, in the sense that there's a lot of progress in this managing space traffic. 10 years ago, we had only a very account of the debris in space, and the monitoring was not so good. So, and we could not control, at least the new satellites are kind of forced to be controllable more than before. So things are kind of improving in both ways. The number of debris and satellite is improving, but also the way we fly in space is improving. And at the moment, things are fine, but I guess in the future, what is very important to do is to remove the big debris, because those big debris are probably the most dangerous for the ecosystem of space. And those big debris are, we never removed it before, and mission comes like ClearSpace is the first step to remove these big debris. And if we clean this big debris, that will, reduce quite a bit the chance of collisions. But of course, we need not only to remove debris, but we need also to build missions that are more controllable, and that after their service come back to Earth and burn into the atmosphere. So it's not only removing debris, but it's also thinking differently the way we build satellites. And hopefully, if we manage to do that quickly and be concerned of the problem, I think we can, we can hope that it will not become a catastrophe.
Thank you very much, Dr. Kneip, and thank you very much for the great question. We had another session yesterday on specifically this topic, the space debris problem. The talk session is available on the Science and Technology Office Tokyo YouTube channel. You will most likely next week find the link on the EPFL virtualspacetour.com website. So please visit this talk session, where also the co-founder and CEO of ClearSpace, Mr. Luc Piguet, also was one of the speakers. Thank you for the wonderful question. I have another question which was addressed to the students, but I think it might be interesting to also ask all the speakers, maybe starting with the students in Tokyo. Was there an event or a person that inspired you to start studying in the space field? Who, or was there someone or something that inspired you, that made you think about studying about space? Or we can start with Chloe first. Chloe, can you go?
Yes, for sure. Thank you, Yuko. Yes, on my side, there was one specific event. I'm not the person that was passionate about space since I was a kid. It actually happened when I was 15 years old, and I came with my mother to the open doors of my university in Burgundy in France. And I met some researchers working on a space mission by the European Space Agency called the Planck mission, which is a satellite in space that aims at exploring and taking the data of the cosmic microwave background, that, if you want, is basically the first picture that we can get of the universe right after the Big Bang. And talking with the scientists and letting them explain to me the different things that we still don't know about the universe really got me into space. And that really was the moment when I realized, okay, I want to do that in my life. I don't see myself doing anything else.
That is super. Ota-san, would you like to follow?
The space educational program is my turning point to start to study or research about universe or space. It's space sounds and in it's very naively space sounds like cool or interesting, and when we research space or astronomical physics, we have to study many things and including not only physics, just also engineering. So if you engaged in space research, you need to study many genre subjects. So it is very interesting point to engage in space engineering or space. It is okay.
Yes, thank you. That's so interesting that the space education program was your trigger, the occasion to get you interested.
Yes.
And now it brings you here today and involved already in careers in space. Kanda-san, would you also like to share?
I belonging to electrical engineering department. When I joined the program, I meet a lot of field of studies. I notice the space. The space is associate with a lot of field studies. Next, I want to study other fields of studies after the space educational program. After the space educational program participants. And I was a mentor of space educational program. I tell participants the experiments what kind of experiments I have done, and what kind of difficulties we had, and how we solved it smoothly and quickly. I told participants then.
Thank you. May I also ask the professors to share their experience, perhaps? So maybe this time I start with Professor Kneip.
Yes, I mean, I was born in 1967. That was just before the Apollo mission. When the Apollo mission started, the first foot on the moon in 1969, my parents bought a TV for this event. And I guess in the coming years, I was following with my parents this event. And so after that, I've been fascinated by space and the universe. And when I was a student, and I wanted to, decide on what the topic I wanted to do. I was really, in terms, I was thinking that I could learn a lot by observing things. And I was undecided to either observe the Earth from space or to observe this space from space. And I decided to go on astrophysics and study space from space.
That is that sounds like a very, since starting from your young age, a very long but a fruitful journey it turns out to be. Now, if I may turn to Professor Ishigami.
Yeah. Well, I may disappoint the audiences. I was not space boy when I was teenager, and when I was high school student, I was pretty much interested in making a film. I mean, movie film. So I was not interested in anything about space. But when I was a university student, I came across a professor, my supervisor, and he told me challenges in space development. And I realized that those technical challenges may motivate me to bring this career in space. And when I was at MIT and I went to several museums over there, I went to Smithsonian Museum and I saw a lunar roving vehicle, the prototype of the lunar roving vehicle. And I found myself that, yes, this is what I am doing. So that those technical challenges may be leading me to the practical or real space things or career in space. Yeah, that's what I have.
Thank you very much. That's actually quite encouraging that most of you did not start out as a space kid, but as you grew older or as you entered university or even proceeding your even as you progressed in your studies, that you became gradually interested is very encouraging that we can think that the horizons are unlimited. Shall I ask for one more comment or question from the audience? Please raise your hand if you would like to make a comment or. Okay. So in this case, since we are quite past our scheduled time, I would like to thank all of our speakers, starting with Professor Kneip, Professor Ishigami, Mr. Ota, Mr. Kanda, and Ms. Carrier, also known as Galactic Chloe. And if you can turn the screen to everyone. Yes. So that we can all say thank you and wish you all a successful space mission on Earth or above. Thank you very much.
Thanks a lot.
Thank you very much.
Bye-bye. Welcome back to everyone to our EPFL virtual space tour. We are at our last session for the talk events. For those of you joining us for the first time, the EPFL virtual space tour is a project that is a collaborative work of EPFL Space Center, eSpace, at EPFL Swiss Federal Institute of Technology in Lausanne, and the Science and Technology Office Tokyo at the Embassy of Switzerland in Japan. At the heart of this EPFL virtual space tour is two science communication projects. One is the Virtual Reality Universe Project, VRUP, which is a project that takes you to a journey through outer space from the Earth into our galaxy and beyond. It is based on the most detailed map of the universe. It is hosted at the Laboratory of Astrophysics at EPFL. And it is an amazing experience that you can try on at the virtual reality goggle headset version here at Tokyo, our Tokyo venue. And also there will be YouTube videos of this project on the Lastro and VRUP websites. So please find the videos there. They have made a very new version for this Tokyo session. So if you have already visited in the past, you will find something new. The second science communication project that is at the core of our EPFL virtual space tour is the Tranquility base. It is an online-based escape game that the Student Association Space at Your Service has developed. And we are today, or right now, gathered to hear more about this project, Tranquility Base, by the president of the Space at Your Service. And therefore, I would like to start without further ado and call on Mr. Alexander de Montelou to show us or present to us Tranquility Base, the project. Alexander, ready?
Thank you so much, Kyoko. Yes, I am, more than ever. All right, so let me start. Okay, so good morning, everybody from Switzerland. Good evening, everybody from Japan. I am so happy and honored to take part at the EPFL Virtual Space Tour. Today, I will present to you Tranquility Base. EPFL Virtual Space Tour is very special to us, my association and I, because it also means the launch of projects we have been working on for almost a year now, Tranquility Base, that I will present to you today. But before everything, let me present you what is Space at Your Service. So we are an association recognized by EPFL. We are specialized in the promotion of space sciences in multiple ways to the general public and the student community. For projects and events, we work a lot with different stakeholders. We're in collaboration, for example, with EPFL Space Center, Space Innovation, laboratories, and also government institution for Tranquility Base, for example. Let me give you a quick overview of what we do at Space at Your Service. So we are known on the campus, and this is what you can see on the left picture. We are known for Astronomy on Tap, which are informal conferences. The concept is the following, is that you go, everything takes place in a bar, and a professional from the space field go on stage, talk about what he does, and after there is a big exchange between the speaker and the public, and everybody has got a beer, so it's more informal conference. Maybe some of you have recognized him, but this is Claude Nicolier that you can see on the left side of this picture, on the top left side. We also organize workshops to very young audience. This is what we call Vivalis Mission. It's a 6 months training for a young audience where we teach them multiple aspects of space sciences. And last but not least, and this is why we'll present to you today, Tranquility Base. If you want to know more about our association, please don't hesitate to go to our website. There are a lot of descriptions and much more projects to show. Before explaining what is Tranquility Base, I think it's important to mention this. This project is special also because it is multidisciplinary. It means that people from very different worlds were connected together thanks to this project. We can count on laboratories, space-related entities, government institution, and also video game studio. And at Space at Your Service, we were coordinated all this work in the aim to create Tranquility Base. Now, let's move on to define what is Tranquility Base. Well, it is an augmented reality multiplayer smartphone escape game on the theme of space. It seems pretty specific, but it's pretty simple to understand. You can see on the left picture someone playing the game. It is actually, as I said, an augmented reality game. So you can have a tablet or smartphone. You scan the ground using the tracking system of the camera of your smartphone. And after a virtual world appear to you. And this is what you can see on the right pictures. On the top right one, both views are taken from smartphone. So on the top right, you can see a picture taken from a smartphone of the lunar base. And on the bottom picture, a picture of the Mission Control Center. So it is a two-player game, multiplayer game. So each person are in a different room. One is on the lunar base, the other one is on the MCC. And the scenario is the following. So lunar earthquake has damaged the lunar base, and the oxygen is dropping down really fast. And you have 20 minutes with your teammate who is in the other room to find a solution and save the mission. So this is an escape game that takes place in two different rooms, and based on collaboration, you will or you will not save the mission. Tranquility Base is pretty unique. It is a science communication tool that have never been seen before in the world for three reasons. First of all, because it is a multiplayer escape game on smartphone in augmented reality. So this is pretty unique. Also, and I will come back to that later, because it contains current space research projects that are virtually present in the game. And the scenario is based on real science. Now, we did Tranquility Base. The purpose of Tranquility Base is to show through research projects that are virtually present in the game, as I said, what a lunar base in 2050 might look like. Also, we want through this game promote Swiss contributions to the space field and show that Switzerland is indeed a really strong space nation. And of course, give people knowledge about space. So I got a quick video to show you, which gives you an idea of what you will see when you will try the game. These views are taken from smartphones. And yeah, this gives you an idea of what I mean when I say augmented reality. So this is a view taken from the lunar base. Actually, the person behind is moving the phone around where he is, and this is augmented reality. So this is a view taken from a smartphone, and this is the Mission Control Center, where you will spend time searching for saving the missions and solve the puzzles. So let's move on to research projects that are present in the game. This is a central point of Tranquility Base, and of course, one of the things that make Tranquility Base so unique. So to make the long story short, we reached for laboratories that were working on research projects related to space. And we asked them if we could put a virtual version of what they are developing into our game by giving them an application. The first research project, is a modular origami robot called Mori from the Reconfigure Robotic Lab. We have the honor to have Kevin Hotcroft, from a PhD candidate from this lab, who has been working on this project for several years. He will much better describe Mori right after my talk. But the very basic concept is the following, is that they developed this triangle-shaped robots that can fit together in the game to create complex structure. And the application we gave to Mori is that Mori are actually the shell of our lunar base that you can see on the top right picture. And on the bottom picture, right picture, you can see a virtual version of Mori that is present in the game. Second project, Amisru from the Thermomechanical Metallurgy Laboratory at EPFL. What they develop is that they extract the regolith, which is a rock present at the surface of the moon. And with this rock, what they do is that they extract the oxygen. And what we did, the application we gave for Amisru into our project, into Tranquility Base, was, of course, that Amisru is the oxygen supply of the lunar base. And last but not least, a spacewalk from the Robotics System Lab at ETH Zurich. It's a crazy robot, and the aim of this robot is to go into spaces that have never been reached by a robot before, especially on other planets. I'm thinking about Mars or the Moon. And the application we gave to Spacewalk, of course, Spacewalk is the exploratory robot of the lunar base. So some of you have maybe have tried the game or not yet, but I will talk about hidden elements, and this is another important way to communicate on space sciences. So I'm going to reveal some of them, but don't worry, there are much more to find. For example, you can see on the left picture that is hidden good luck peanuts that are present at every NASA's launch. On the middle picture, you can recognize, maybe some of you can recognize, a Swiss cube. Swiss cube was a satellite developed in 2009 by 250 students and was launched to space. And believe it or not, but there is a lightsaber on the right picture. This is because back in the 90s, lightsaber was brought to space. It was a lightsaber taken from the Star Wars movies. Oh, okay, oh, great. What is the future of the game? Well, the game is made to evolve. We want to have more puzzles in the game. And of course, and more than ever, we want to have more research projects in the game. We want this game to getting bigger in the future and travel the world at many events. From now, we will be at Dubai World Expo in October 2021. As Kyoko said, the game is available in the App Store and Play Store, so please tap Tranquility Base on your stores, and you will be able to play it at home. And I can't wait to let you experience the game by yourself and see how incredible this game is. If you want to know more about Tranquility Base, don't hesitate to go at our website. There is everything I talked to you about, but also some more information. And also there is, for each hidden messages that you find, there is a description that explains why this hidden messages is here. So I encourage you also to search in the room for these hidden messages. There are lots, and each hidden messages are references in our website. And if you have any question, I would be more than happy to answer them. So please contact me by my mail below. Last but not least, I would like to thank all our sponsors. Of course, it started a year ago as an idea, and it's crazy to see that right now it has gone so far, so fast, and that the project is actually that good. This is the last day of the EPFL Virtual Space Tour. I would like to thank everybody who were involved in it, but also everybody who were involved in my project. Vincent de Rouen from EPFL Space Center, and Kyoko Suzuki and Tomoya Dunki from the ST office. Thank you so much. It was amazing working with you, and I want to keep working with you in the future. Thank you.
Thank you so much, Alexander, for your kind words and also for the comprehensive overview of Tranquility Base. I have to confess there were some hidden elements that I didn't realize. So I look very much forward to going back to the Space at Your Service website and learn more about these hidden elements that will give me even more background history about the history of space exploration. I understand. In addition to all the fascinating research that is shown in this virtual escape game, next to me, everyone can see that one of the research projects, the Space Block, is here at the Tokyo venue. So people in Tokyo are very lucky to see the actual research project that has been brought from Zurich. Thank you to our collaborators for that. And unfortunately, we do not have the origami robot here, but we do have Mr. Kevin Holdcroft, from the Reconfigurable Robotic Laboratory at EPFL to tell us more about the modular origami robot and folding space. Kevin? Are you ready?
Yes, I am. Thank you very much for the introduction. And I am very much looking forward to sharing this research with you all. So as stated, my name is Kevin Holdcroft. I am a PhD candidate in the Reconfigurable Robotics Lab under the supervision of Professor Jamie Pig. So I've been researching this topic for the last several years. And without further ado, let's get right into it. So, 1 second. Oh, there we go. So first off, let's talk about our goal. Why are we researching modular origami robots? Our goal is to rethink the core concept of robots in space, to rethink how they can approach the range and flexibility of current systems and how we can expand on this. Our goal is to replace individual robots that are designed for an individual task with a single robot that can be adaptable for many purposes and many goals. So we're working on a new framework that can be used during robotics missions in space. And this is adapted, tailored, and extended to suit a range of unknown tasks. So let's talk about reconfigurability in robotics. This is something that is extremely is a hot research topic right now, for lack of a better word. And reconfigurability is the ability to change the shape and function of a robot to augment different applications, environments, and users. So for example, reconfigurability can augment a single function. So in this case, this robot is able to change its shape to perform different locomotion, different forms of gait. So it's able to walk as an insect and as a quadruped just by changing the angle of its spine. It can combine multiple functions into a single robot. So this robot is able to walk like a walking dog, like a quadruped, but then it's able to take off like a drone and fly away. And reconfigurability can actually serve as the function. So in this robot, different pieces fit together and interact with a human user. However, this comes at a cost. These robots are typically more complex, and this complexity is due to the need of this morphological and functional change. So if you were to have just a flying drone, you wouldn't need to worry about legs. If you were having just a legged robot, you wouldn't need to worry about transforming to a flying drone. So this leads to extra mechanical, computational, and electric considerations when designing these robots. A good example of reconfigurable robots is origami. So many of you, I believe, will be familiar with the concept of origami, which is the art of paper folding. And we use origami to transform 2D patterns into 3D shapes. So a good example is this one we have right here, where we see in the top left, we have a little origami sheet that is able to transform into an origami boat just by itself. Now, it's not only used to change its overall shape, but using an origami hinge, we can connect this to satellites and thus be able to direct solar panels to face the sun and absorb the most amount of energy possible. Origami can also be the core structure of the robot. So in this example, the robots are actually assembled flat on a 2D plane and then fold up into little 3D shapes, which are actually able to crawl and jump and explore. And this leads to extremely low-cost robots and mass manufacturability. We're not the first to think about origami in space. This is actually quite a common trope in science fiction. As is seen in one of the Star Wars movies, there is a ship which has a solar sail which folds out and powers the ship. However, origami does have its limitations by itself. It does have its complexities. In general, you need a predefined geometry. You need to fold along the predefined fold lines. It's a bit less forgiving than when folding paper. And similarly, while you can change its shape, it's very difficult to make an origami robot address many, many, many different tasks. Usually they're designed for one or two in mind. And lastly, and this is the one I think is quite interesting, is they are limited to the size of the sheet of paper. So if you want a very, very large origami robot, you will need a very, very large sheet of paper. And this material can end up being in the range of meters and becomes unscalable quite quickly. So let's go back down to earth and let's talk about modular robots. Modular robots contain self-contained little entities that connect together to form full functional robotic systems. So in order to best demonstrate this, let's take a look at this one right here. This example right here consists of entities that are little black and white entities, and they connect together to form a crawling snake, or they can change their shape to form a little walking dog. Being a modular robot can mean you can actually adapt to how you interact with the environment. So in this example, these little robots are able to connect and disconnect from the core structure and reach heights and locations that they normally wouldn't be able to. And in this case, each one of these little black cylinders is able to expand and contract and change the overall shape of the robot. However, of course, they come with their own limitations as well, which is they have limited range of motion, specifically along where they connect together. It is very difficult to control these robots as each entity needs its own degree of control. It needs individual control for each entity as well as for the whole robot. So this adds a lot of complexity. And of course, since it's consisting of a lot of individual pieces, there's different considerations when designing the physical connectors. The computational cost is quite high, and each function currently is programmed according to the task. So to overcome all of the limitations we've addressed before, we decided to combine origami and modularity. This gives us the geometric flexibility of origami robots, the ability to fold and form different structures, and the functional versatility of modular robots, the ability to change the shape easily to perform different functions. So this graphic really describes what we're trying to do. We have individual triangles that can connect together to form a robotic sheet, robotic gripper, robotic tubes. So in this video you're about to see, we have little triangles that disconnect and reconnect and form a little walking quadruped, a little walking dog. But the same triangles can reconnect to form a little robotic arm, a manipulator that interacts with a ball. And this is a render, this is something virtual. So what about in real life? Well, we did just that. We made Mori, modular origami. So Mori consists of quasi 2D modules, meaning they are fairly flat, but not exactly, that are manually attached together, and they can fold into different 3D shapes. So as you can see left, we have one actuated module, and they fold together, they connect to other passive triangles to form a little tetrahedron. There's different, so what can we do with the Mori? It can be a reconfigurable surface. So in the bottom one, we have just two actuated modules able to control all of the other triangles to resemble a little surface, kind of like you would see in the Batman cape in Christopher Nolan's Batman trilogy. These modules are able to crawl around on the ground by themselves under their own power, and when connected together, can form a 3 degree of freedom platform. So when we add a platform on top with markers for a camera, it's able to actually balance a ball just by itself. So what comes after this? We've introduced the Mori 2. The Mori 2 has an automatic coupling mechanism, and you might recognize this little render as the one that exists on the Tranquility base, as Alexander was previously mentioning. So with this version, we are able to have edges automatically retract their pins, connect together, and establish both a mechanical and electrical connection. So these are able to actually talk to each other, communicate to each other, but then as well, there's mechanical protections in place where if you were to force them to bend, the teeth would actually slip on each other and not break the overall robot. So where do we go from here? We are developing a research platform for reconfigurable space robots. Now, this platform has been in design, and this has been something we've been researching for the last few years now. And it is something brand new that the world's not seen before. It is funded by the Swiss Space Center, the European Space Agency, and the Swiss National Center in Competence in Robotics. And it combines the versatility of the Mori 1, the ability to perform different functions, the automatic coupling of the Mori 2, and a third twist that unfortunately I can't tell you guys about just yet, but keep your eyes peeled because it has been submitted to a high-end journal, and I am so excited to introduce this wonderful piece of technology to the world. It's something we have been looking forward to for a very long time. So what's its potential? We have small triangles that are able to connect together and form large volumes. So this means it's very easy to transport these modules on a rocket ship, for example, because they occupy very little space, but they're able to fill large volumes. The Mori are able to perform different robotic tasks just through programming. So this means that if the astronauts on the ISS or on a space mission want a new robot, they don't have to contact Earth and be like, we want a new robot, which would involve a long design procedure, and they would need to ship the robots into space. They could just reprogram the robots they currently have on board the ISS and on board their rocket ships to create a robot that resembles what they need. So this has a very large application range, including astronaut assistance, maintenance and inspection aboard spacecraft, and exploration. So this concludes the technical element of what we're talking about, and I'm going to leave you guys with a bigger version of the renders of our vision. So this includes Mori that are helping astronauts by holding objects, Mori that are helping fix solar panels, Mori that are that resemble a 3D surface. So this could resemble the topology of a planet's surface to help astronauts understand the surface of a planet more, or it can connect around an astronaut's arm to become essentially a third arm. And with that, I will leave you all with this image, and I thank you so much for paying attention and for your time. And we'll stop share.
Thank you so much, Kevin. This was, we could really feel your excitement. And it also, I think, moved us in the direction that we really look forward to seeing Mori in space. I would like to now invite our audience from the Tokyo venue and also online to, if you have any questions for our speakers. For those of you listening in from our Japanese channel, you are very welcome to ask your questions or type in your questions in Japanese. If you are at the Tokyo venue here, please raise your hand. Someone will bring you a microphone, and you can also ask questions in Japanese or English. And I think we have a first question. Thank you.
いわゆるそのものを折り曲げて立体化して作る場合、だから折り曲げる機構は非常に素晴らしいんですけど、いわゆるそのバラバラの合体させる機構もあればもっと柔軟度が増すかなと。ただ、つなげるとなると配線のあれとか可動部分だ、まあその制御的にもっと複雑になるでしょうけど、いわゆるそのいわゆるその独立で、制御系のことも、電源が1箇所だけじゃなくていろいろ複雑になるでしょうけど、ドッキングも踏まえて考えるずに、全部一つのあれで折り曲げていくことを考えるだけじゃなくて、そのセパレートに分かれて合体とかそういうことも考えるとまたメカニズムは複雑になるでしょうけど、その辺はどうなんでしょうかと。
Thank you very much for the question from the audience in Tokyo. This is for Kevin. So in Mori, it seems you are bending the robot to make the devices or the devices that you wish to. And if you think about combining mechanisms, or rather building them up, perhaps that will bring more flexibility, flexibility to your robots. It could bring also complexity in terms of the circuit wiring and where to ensure the power source. But would you consider building up the robots instead of combining the building up the robots? And I think you have a good answer for that.
To clarify, if I understand the question well, you're asking why we have them automatically connect as opposed to connecting by hand?
No, I think excuse me, there might be a misunderstanding that the robot is being bent.
No, yeah, the joints themselves, the robots are not being bent. Each edge of the robot has a little tooth mechanism that can retract and connect to each other. And then using a gear train in a specific configuration, we can use classical DC motors to actually rotate each joint. So it's a mechanical connection that is powered by a DC motor and a gear train to that location, to give a technical answer.
Thank you. I see the person asking the question nodding, so I think this made a lot of sense. Thank you very much. Would someone else like to ask another question? We have another question. Thank you from the Tokyo audience.
ありがとうございます。レッコンフィギュラビリティっていう概念、すごく面白いなと思いました。で、その中で、ちょっと確認、質問なんですけれども、複数のものがこう一つのものになるときに、どこが頭になるのかっていうのが気になっていて、個々すべてのものがそれぞれ頭脳を持って動いていくのか、それとも合体をすると一つにこの形としてこうなんでしょう、一つ何か頭脳を置いて動いていくのかっていうとどちらなんでしょうか。
Thank you for your question. So again, about the Robogami or the Mori. So the concept of reconfigurability is very, very interesting. And the question is, when you combine or start to attach these different pieces together, which part would act as the brain? Is it, or does it work as a total, as a sum, or the comprehensive part? Is it it acts as one, and there is no particular brain to the robot?
That is a very interesting question to which there is no real answer for as of yet. This is an active area in something called swarm robotics. Swarm robotics are the study of how robots work together, whether they're combined or not. And in our case, it's a bit of all of the above. We do have a central coordinator, we call it, but each robot has its own degree of autonomy. Each Mori is its own autonomous robot. But we do need to tell the robots where to go. And so it's a very difficult question because if you think about biology and if you think about how different organic cells can create a human, these cells kind of have their own degree of autonomy. They know their function, but we still have a brain to move all of our cells together and move our body to create work. So it's a very it's a very layered question that in terms of being an autonomous system, it depends on your purpose, what you have available, and how you want to structure your control architecture. So I hope that helps answer your question. It's a very, look up swarm robotics and the control on that side. That would help if you're interested to research that area. It's a very interesting topic.
Thank you for the answer. I see the audience nodding, so I hope there was a trigger for even more exploration. We have another question from our online audience to Alexander. Will you add more research projects in the Tranquility base in the future? Will there be more puzzles in the Tranquility base?
Thank you, Kyoko. Yes, of course, this is the main goal of this game, as I said, is to really evolve in the future, including more research projects and also including the enhancements, the next version of research projects that are already present in the game. We briefly discussed this point with Kevin, for example. Maybe we were talking about maybe including Mori last version into our game. So of course, and more puzzles as well. We would also like to add more levels, like maybe we need to think about it. But for example, now we have 3 puzzles, maybe build another level, which would be harder or different, and there will be probably another 3 puzzles. So this is, I would say, the game that we have right now is pretty elaborated for sure, but for us it is like the base of something bigger. I hope that answers the question.
Thank you, Alexander. I actually have another comment or request to you from our audience in Japan, or online audience, who tried to download Tranquility Base, but their device was not high-end enough. And the person put in a comment, he or she would be very happy if the Tranquility Base can be downloaded on more devices, and looks forward to being able to play at home on his or her device.
Yeah,
So
if I can
it
add,
seems you have much more work to do.
yeah, that's correct. But if I can add a comment on this, it is also linked to the technology that is used, which are high-level technologies. So only phone, like high-handed phones, have this technology. But it's a good remark, and we will work on that, find a solution. Thank you.
It's a reflection that there is more demand. So
yeah, it's a good reflection.
May I also invite another question from the audience in Tokyo, if you would like to? Oh, we have another question.
Hi. Yes. Thank you to. Yes. Sorry. Thank you to both our speakers today. So I have more questions for Kevin, but first, I would like to say thank you, Alexander, for the Tranquility Base experience. I've had a lot of fun playing it here. No one died at the lunar base. That was good. So yeah, thank you again. And my questions for Kevin, really quickly, if he can reply, would be first of all, if the Mori device has been tested in zero-G conditions, either at the International Space Station or in a parabolic flight or similar. Second, what is the approximate weight of each Mori piece, if I can know? And third, last of all, if when can we expect the results of this publication that you were talking about? Thank you.
All right, thank you for your questions. Sorry, can you remind me of the first one again really quick? I was thinking of the answers to the other two.
Sorry, see if the Mori device has been tested in zero-G.
Right,
conditions.
right. It has not yet. So our lab is putting forward a research proof of concept. To actually get this into space requires a lot more considerations. Like, for example, radiation. Radiation is a very troubling factor for electronics in space. I think that a lot of the lunar vehicles right now actually use chips that don't use the fastest processors they can, because they need electronic channels to be wide enough such that they can be robust for radiation. And this is something that I nor anybody in our lab are experts in. So we are trying to present a proof of concept where we can present research on Earth, and then we hope that eventually a team at the European Space Agency, at Swiss Robotics, or even NASA, wherever, would be interested to take this project further and actually bring it into space. I believe that the European Space Agency does have a lot of interest in our project as is. In terms of weight, I'm not going to say exactly because I'm not sure exactly what I can say. The ones you saw in the original video, the Mori 1, is about 30 grams, so it's quite light. And the ones we have currently are larger and in the range of, we'll say, 100 to 300 grams, somewhere around there. I'm not going to tell you exactly because I don't know what I can say. And then the last question was about the date, and unfortunately, this is outside of our hands now. So we hope for within a few months. So hopefully by the end of the year, that's what I would expect. And then, so keep your eyes peeled, but it depends. It's outside of our hands at this point. So
Perfect. Thank you very much.
yeah, thank you as well.
Thank you very much for asking the question that I had actually about zero gravity. May I invite more questions from the audience? If you would like to raise your hand, if you have any questions or just a comment on how you felt these presentation, the game, if you have experienced it, your impression or about the presentation, what you thought about it. This is also nice to have. We have another hand. Thank you. Oh, and we have a second hand. So
Thank you to your presentation. I have one question. What is the most difficulties about mechanic or electronic when you proceed in your project?
Oof. Is this question directed towards me to clarify?
Yes.
So that is a doozy of a question. So with mechanics, I'm going to say to retract the couplings, we are using something called a shape memory alloy. And how this works is it's like a soft metal, but when you heat it, it returns to its original form. So we have one coiled kind of like a spring. And when it's cooled, you can move it back and forth and it's fine. But when you heat it, that's what actually retracts the edge such that they connect together. However, they require a fair amount of power and they are quite, for lack of a better word, finicky. They're quite fragile. And using that was quite a challenge, but we needed something that had a very low profile, like that was small enough and strong enough to be able to retract the spring. And this is one of the only things that could provide this amount of force. So mechanically, I would say that. Electronically, I think from our perspective, it was about scale. We had to produce a large number of electronic boards, and we did almost all of this in-house. And if we have however many robots, and something goes wrong once in a while, it is very difficult to troubleshoot. And I think it's just the mass manufacturing of this that was the issue with the electronics. This is something that can be easily fixed in the future if this was to be properly mass manufactured through proper tools. So I hope that answers your questions.
Thank you.
Thanks again.
yes, thank you very much. I see a big nod. Thank you for the question as well. Would the next person like to? Oh,
さっききちんちょっと質問きちんと言わできなかったと思うんですけど、いわゆるその折っていくの非常に素晴らしいと思うんですけど、中秋いわゆるその命令を出す部分から全部にそのまあ命令を出すところがどっかに置いといて、それであとは制御もだから全部にその判断するデバイスを置いてなのか、でもし合体させるんだったら一箇所でのデバイス情報で、そこから電波なりレーザーなりで通信を送って合体させたりで、折り曲げるだけじゃなくて、その セパレートに分かれてドッキングも自由にできたらもっといいかなと思ったんですけど、でも、その電源の問題とか、いろんなところが、どこに置くかどうかとか、やっぱりそのロボットの全体のどの辺に電源とか、いわゆるそのいろんな判断するのを置いて、まあ、全部の部位に置くんじゃないと思うんですけど、どうなのかなと思いまして。
So if I may sum up the question from our Tokyo audience, thank you for the question. So it seems that it would make more sense if, or would like to know, actually, the question is, where is the power source and the control system placed at? It's probably not in all of the robots, but where would it be in the completed device?
Thank you for the summary and for the question. So in the first two robots that you saw, they were actually wired, so the electronics were off board. In the new one, I can comfortably tell you that we have batteries on board each individual module, and I actually have a paper addressing how modules can share power to improve the runtime of the overall system. The control that we currently have is, I think we're actually going to make a publication on that later, but the summary is we have 3 levels of control, each handling different purposes in the robot. Some which handle the robot's functions, some which handle communication, and some which handle the overall goal and hierarchy of the robot. So I hope that answers your question well. Thank you again.
Thank you, Kevin. And actually, we had another question.
Hi. 先ほど宇宙で使うときの課題として耐久性、放射線の耐久性があるかなと述べられていたんですけれども、他にも例えば、運ぶペイロードすることと、あとは処分することっていうのも課題になるかなと思っていて、そこをどのように解決していくかというのをお聞きしたいです。
Thank you for the question. You mentioned, again to Kevin, you mentioned the challenges of durability in outer space, but are there challenges also in terms of bringing it up to outer space, the payload issue, and also disposing of the modules in space? What are the challenges and how do you plan to tackle them?
So thank you for the question. I'm going to openly state again that this is not a particular area where I am an expert. I do not know enough about payload packing in space in order to make a definitive statement on your question. However, in terms of disposal, something interesting is what's been brought up is actually the use of MORI as space debris removal. So it's quite well known that there is a lot of particles and leftover debris in space right now, and being able to use a mass manufactured device that can wrap around objects of variable size and then send them into the atmosphere to burn up is actually a viable option for removal of space debris. So I'm sorry I won't be able to answer your question probably to your satisfaction. This is an area that we will likely look at a later date when we look to send these actually to space. But yeah, it's a good question, and thank you for it. It's the right questions to ask.
Thank you very much. I saw a big nod again, so think it was to the satisfaction to our nice guest. So now that we have exceeded our planned time quite considerably, I would like to thank everyone. First, our speakers, Alexander and Kevin, who have given us very interesting and exciting presentations, if we can call them. Yes, thank you. It's nice. I would like to also thank our space BOC, EPFL eSpace, my colleague and friend, I hope I can call him now, Vincent Duran, for all the work he has done for the EPFL Virtual Space Tour. I would like to thank our audience, both at the Tokyo venue, as well as online, both on our Japanese and English channels. I would like to thank my team and all our collaborators at EPFL. I cannot name them all, but very, very heartfelt, big thank you to everyone. And with this, I would like to conclude the final talk session of our EPFL Virtual Space Tour in Tokyo. We still have some more demo sessions that we may be able to do before really finally closing. So to those of you in Tokyo, please, in the Tokyo venue, please try them out. And at the end, if you could join me in giving a big round of applause to Alexander and Kevin for their great presentations. Thank you.